In order to demonstrate this idea of surface tension, I have a little demonstration set up. Now, I've told you several times in the early part of the lecture just how bad the soft drinks, especially the colas, happen to be. The surface tension of soft drinks is so resistant that, unlike the bug here, we could almost walk on the surface of a soft drink with it. But it has a lot of nasty stuff. We also know that it is extremely acidic. So what I want to demonstrate is how if we change the environment in this soft drink, can we get rid of the acids and the chemicals and some of the other things that were built up in it, much the same way that we do with the metabolic waste in our 76 trillion cells. So I'm going to take one of the coral sachets, and I'm going to put it in here and watch the reaction that is going to take place. Because what you're seeing now is the ionic organic minerals reacting with the acidity and the other chemicals that are in this particular product. And the correlation is there. It's the same kind of thing that getting the body alkaline does within the body, getting rid of metabolic waste. And of course, like I said, this now lowers resistance. It's much easier to get the ionic or the materials, especially the nutrients in, and the other materials out. So that's a very good representative of what takes place in your body when it becomes more alkaline. Okay? All right, let's go on a little bit. Because I talked about free radical damage. Well, there are 3 different levels of free radicals. 2 of them we've grown up with. Again, we've learned to work with them. There are chemical free radicals, the chemical reactions that take place within our body. There's digestive free radicals. Okay? And then there are the things that we are now being bombarded with that we call environmental. This also goes along with some of the foods and the additives that we have in there. So these are the different kinds of free radicals that we're dealing with. So what is a free radical? A free radical is nothing more than a molecule that is unbalanced. Now I'm giving you the short version here. So on this side we have what we refer to as a molecule that's balanced. You see it has all of this little electrons there. Each one has a little pair. Our unbalanced one on this side isn't. Now, in a stronger molecule, it's going to try to steal an electron from this particular one to make itself balanced, very much like this. So as it steals this electron, okay, one side is now going to become balanced, but now the other side is imbalanced, and it has to go looking for an electron. This is almost like a small atomic explosion taking place within the cells of the body. Okay? Very detrimental. Now, what happens is that in the bloodstream, we can see this. On the left side over here, again, we have a nice picture of alkaline blood, okay? All nice, pretty little erythrocytes there. But when we have free radical damage taking place, in other words, we're stealing those electrons, it happens within the membrane, and I said it's just like little atomic explosions. It blows holes in the membrane of the cell. And so on this side, you can see some of that type of thing that's taking place. This is free radical damage. Now, obviously, in the cell or in the bloodstream, this is going to greatly inhibit the amount of oxygen that is being transferred or taken to the other cells. But blood cells don't have a nucleus. I mean, this is not good. But blood cells don't have a nucleus. The rest of your body's cells do. Now, this happens to be a skin cell, and you've all seen this in biology at one time or another. You see that this is a cell that is actually replicating, dividing. And you see how the chromosomes are being pulled apart. Well, at this particular stage, they're extremely vulnerable because we're hunting for free electrons. Chromosomes have a lot of electrons to steal. And so free radicals, once they get into this level of things, begin to steal free radicals from those chromosomes. Okay? And so as it goes through, it's like a little X-ray machine. As it goes through, it just picks up that electron and away it goes. Well, when this finishes dividing, now you have an incomplete cell. And usually the cell that's the electron that's the easiest to steal comes from what's called the p53 gene. It's the biological clock of the cell. It tells the cell how long it's going to live. What's cancer? Cancer are cells that, for some reason, the p53 gene has been interrupted or stolen, and it doesn't stop replicating. Just continues to grow. Well, one of the things that we can do with this is that we find that we can replace that p53 gene. Okay? But when you're alkaline and you're taking in the ionic coral minerals, then the free radicals are being overcome so that this doesn't take place, or at least not as readily. They say that you face this type of condition about 10,000 times a week. So your body's immune system better be strong, and you better have a whole reservoir of antioxidants to fight this type of thing that takes place. So when you give antioxidants, what happens? Well, it really fights these free radicals in three ways. First of all, the antioxidants can actually set up a physical barrier so that the free radicals can't get to the surface or the membranes or the chromosomes within the cell. It actually blocks them from getting there. Now, another one is that most antioxidants actually carry extra electrons, if you will. And so it's kind of like, okay, free radical, here, I got a couple of extra electrons. Go ahead, just take a few. And of course, when you get the electron onto the free radical, it's no longer a free radical. The third thing that's interesting is, again, antioxidants, once the membranes or whatever are destroyed, can donate electrons and repairing material to those cells. So these are the three ways that antioxidants work. Now, as I said earlier, this is a reminder. Placing a sachet of ionic coral minerals into pure water, and I prefer distilled or reverse osmosis water, that's where you get the best benefit, releases billions, we think there's even trillions of free radical fighting antioxidants available for your body to use, building up a nice reservoir to fight those free radical damage problems. Okay? So, I just ran across this, and I didn't have a great place to put it, so I think this is an interesting place for it to come. Because Herman Ahara, who actually wrote the book, Acid and Alkaline, a very informative book, simply says this, okay? For every 100 milligrams of calcium in 100 milliliters of blood, there are 60 milligrams in crystal form. That means inorganic. And we do need that. We don't want everything ionic. And there are 40 milligrams of ionic organic in there. But here's where the real rub comes. When one gets sick, when you're extremely tired, or if you're extremely stressed out, this ratio changes. Because what happens is that the inorganic pretty much stays the same. But the ionic organic minerals begin to drop. And in the case of the calcium, it decreases to about 15 milligrams. So remember what I said earlier? We've got to take an infusion of ionic organic minerals constantly so that the body works the way that it should. And this is a great example of the way that stress is going to work on the body in order to decrease those alkalizing minerals. All right. So let's go back to our first premise when we were talking about the ionic coral minerals. Well, we like to put them into three forms. Again, the powdered form, the sachet form, and then we have the powder that goes into the capsules. Well, I've already said that my personal preference, and the one I use most for my clients, is in the sachet form for a variety of reasons, which I'll cover in just a moment.